Hello, my name is Dominikas and this is our little home project, smartphone controlled car with video feedback. This was made by me, Dominikas, and friend Paulus. I did the software side where he did more of a electronic side. So, what is all of this? Well, first of all, this is a extendable controller for a smartphone or tablets, Bluetooth controller. Then we have a Windows tablet. Well, it's not exactly Windows tablet. It's a tablet with Windows. It's not the expensive one. Then on a car you have Raspberry Pi, Raspberry Pi A Plus, I think, or is it A, the old one. Then you have Arduino based motor controller, power bank, general use power bank which I use to power Raspberry Pi, and you got LiPo battery to power the Arduino based motor controller. What else? Then obviously you see there's a small camera, Raspberry Pi camera module, some wiring, zip ties, cables. What else? We also had some Arduino based Arduino controllers and motor controller, but the idea changed slightly, so all of this became redundant. Or if you're controlling a car from your home, from your laptop or PC stationary, you can always use an Xbox controller. It can do the job just fine. How it all works? Well, first of all, you have a Bluetooth controller connecting with a tablet. You don't need to do much here except pair them together, and then the tablet sends the data of key input to Raspberry Pi, and Raspberry Pi relays data to motor controller. And the video wise, you got small camera, small camera in front. It captures the video, and Raspberry Pi sends the data to a tablet. So yeah, and like I said, this power bank is for Raspberry Pi, and LiPo battery is for motor controller. Two power banks mainly due to different voltage, because LiPo battery I think got 11.1 volts and Anker only has 5, so there's a bit of difference. Yeah, so yeah, that's how it all works. Short story. Powering it up. So first of all, we power Raspberry Pi on. Then we power the motor controller. Yes, we power the motor controller. Then we connect motor controller with Raspberry Pi. Yes. Then what happens? We need to connect with Raspberry Pi and start the program. Yes. And that's supposed to... Yep, it works. There's 100 different speeds, so to demonstrate it. Yep, that's it really. So now we turn to onboard car camera. As you can see, the quality is not great, but it's about finding a sweet spot, because the high quality picture is accompanied by more data, and if any of the devices in the pipeline too slow to process that data in real time, then that will start building a noticeable latency, which is not an option in this project. So in this case I settled with something less, still decent. And now you can see, since on monitor there is a display, an output of camera, you can see some magic going on. But yeah, the car is pretty stiff. If you accelerate slowly, then it's fine, but if you use full throttle, then it's a bit shaky. But then again, what do you expect from 20 pounds radio controlled car? So range with given devices, it's no more than 40 meters, which probably is equivalent to original radio controlled range. Battery, the original radio controlled battery would last stops 15 minutes, around that. With new battery, I estimate should last at least an hour, but I haven't tested that yet, so can't say for sure. The software side, there was a bit of coding involved. On tablet, the input is captured using direct input and small TCP server with a couple of threads. That is all under one program written in C++. On Raspberry Pi, you have fairly simple program written in Python that relays data to Arduino-based controller. And of course, on controller, you have a program that handles the input and sends the signals to the analog signals to the motors. The video feedback. That is something that I struggle to get working on a real-time basis, because there are quite few solutions on transmitting video data from Raspberry Pi to your machine, but very few of them do it in real time. So my solution was to have a single ISP video call on Raspberry Pi with all kinds of parameters, including your machines on which you're going to view the video IP, and on your machine use a Netcat and MP4 player. It all works great. Extensions. As I mentioned, devices use Wi-Fi to connect to each other through local network. That network could be made public, so you could connect the device from pretty much anywhere. If you provide your car with mobile internet, then you can leave your car in the middle of the field and control it from your phone, or drive it anywhere within mobile internet coverage. So that is pretty neat idea. Or if we are thinking a bit in smaller scale, then some equipment would need changing. That 40 meters range comes from this smartphone, which primary function is definitely not to be a Wi-Fi hotspot, and on the other hand you got this extremely small thing, a Wi-Fi adapter, a Wi-Fi dongle, costing me like £1. So if we replaced all of that with something more serious, with more powerful, so I'm pretty sure we could go beyond 40 meters. The motor controller comes with some neat features such as current monitoring, accelerometer, and collision detection, which are all crucial when it comes to autonomous handling. As well as you can connect up to 6 servos, which is again pretty useful. Data transfer. The communications are already there, so we can easily add another gadget to the car, such as let's say laser for distance measuring, and then they send data back to the tablet. It would be pretty easy. The cost: £20 for extendable joystick, £20 for external battery, another 20 £25 for LiPo battery with charger. Raspberry Pi is another 25. Camera module costed £15. Let's say we also add a tablet, which is another £75. The chassis itself comes from Radio Control Car off Amazon. Costed another £25. Wires, accessories, add another £20. Electric tapes and stuff. So it all adds up to actually quite a bit. So the bottom line, as a software engineer, all the changes, all the work I do, I only see in monitor. To me, this was a proof of concept. Can I actually move physical object in controlled manner? Yes, I can. Sure, car is not pretty. I mean, half of the original car parts are ripped and bent, and that was replaced with a laptop cover that is screwed to the chassis of a car with wood screws, and most of the things are tied with zip ties. So, but the looks are beyond the scope. Thanks for watching.